you are mostly famous for creating the laser, the maser, and helping creating the radar. So could you please tell us, how did you come up with the idea of the laser, creating the laser?
There are two lights
Well,
here.
now that's a little bit of a long story, but I'll be glad to tell you about it.
Oh, have a comfy chair.
During World War
There's a very
II,
nice
I
chair.
worked on radar, so I learned a lot about microwaves, and I discovered that microwaves could tell you something about molecules. You study molecules with microwaves by looking at the absorption of microwaves on molecules. And so I was studying molecules and atoms and so on, doing spectroscopy it's called, studying absorption of microwaves. And we're getting a lot of interesting results and finding out the shapes of nuclei and lots of things. And I was at Bell Telephone Laboratories when I started that, but the work was successful enough that people offered me a job at Columbia University, so I went to university, and I really like universities. And I was working there for some time, and I wanted to get still shorter wavelengths. Now the microwaves would, of course, use radio oscillators, and they could be made wavelengths as short as about half a centimeter. That's about a quarter of an inch. You get them down about that short, maybe a little bit shorter, but people kept trying to get shorter, and they couldn't build anything to get these short waves. Now I wanted to get the shorter waves to do spectroscopy, a new kind of spectroscopy down shorter waves, down below a millimeter, and which is known as the infrared. It gets below a millimeter, that's the infrared, no longer microwaves, but infrared. I want to get them down below a millimeter. I tried a lot of ways trying to do this, and it didn't work. And I was made chairman of a committee, a national committee. The Navy asked me to be chairman of the formal national committee, and I picked a lot of outstanding engineers and scientists. We traveled all over the country and even to Europe to try to figure out if anybody have any ideas how to do this. And after I'd been doing this committee, it had gone about a year. I was going to have our last meeting. We hadn't been able to get any answers. It was in Washington, D.C., and I woke up early in the morning worrying about, gee, why haven't we been able to get an answer? Breakfast wasn't ready yet, so I had to go out. I went out and sat on a park bench, and the sun was nice and bright. I thought about it, and why haven't I been able to get this? I've tried this and that in various ways. And of course, molecules and atoms produce infrared. They produce light waves even. But I knew thermodynamics said you can't make more than a certain amount of power unless you heat the molecules or atoms way up. You have to heat them so hot to get enough energy that they'll fall apart, and so you can't get very much. I said, hey, wait a minute. They don't have to obey ordinary thermodynamics. Ordinary thermodynamics says you have to have more of them in a lower state than an upper state. And hey, they don't have to obey that. I can pick out molecules mostly in an upper state, and then they will amplify and then get as much, if we can get enough of them, get a lot of power. Hey, oh boy, that sounds like, and I pulled out an envelope from my pocket and wrote down the equations, and it looks like it probably can be done. Well, I went back home and wrote it down in my notebook, so I knew it was patentable and so on, to do this. Now there's the idea, the recognition that if you have molecules in an upper state, a wave comes by, they will give it energy. Molecules in the lower state, the wave comes by, they take energy from it. The trouble with thermodynamics is there are more of them always in the lower state than the upper state. But you don't have to obey thermodynamics, you pick out a special collection of molecules, and you have to know how to pick them out. Molecules or atoms, then amplify, and Einstein recognized that happened, and everybody knew that. Most physicists knew that. They just didn't think about how to use it, you see. Didn't think about how to use it. New ideas are really new and surprising, and yet after they've been known for a time, they seem kind of obvious. By now it's obvious. It seems so simple. Now I went back home to the laboratory to try to make it work, and it took quite a while to really get it working and get it going, but we managed. Well, I've told that long enough now. You may have some other questions.
What project were you working on when you invented the laser?
Well, the idea came along. I was doing spectroscopy. I was doing spectroscopy. I was studying atoms and molecules and the nuclei within the atoms and molecules and the structure and so on. That's what I was studying. And it's out of that that the maser and the laser came.
Did you ever expect that the laser would be so common in everyday life?
I knew it was going to be useful. I could see a number of uses for it, very important uses. I recognize that. But it's been a lot of other uses I didn't think of. For example, in medicine, it never occurred to me to be useful for medicine. But not everybody saw that. Now, for example, the maser, I originally invented the maser when I was at Columbia University, and that was just my idea. But that was really the basic maser and laser idea. They're both the same kind of thing, they're just little different wavelengths. And I wanted to get to short wavelengths when I first built it in the microwave region, because I felt that was the easiest thing to do, to try it out there first. And so we built upon working in microwaves, to amplify microwaves first, but it was really basic for shorter wavelengths. However, to push on to the laser, I was consulting with Bell Telephone Laboratories at the time, and my brother-in-law, who'd been a postdoc with me and married my kid sister, he was working at Bell Labs, and I told him, well, I see how I can get right on down to light waves even with this. And he said, oh, I've been wondering about that. Could we'll work on it with you? I said, oh, well, okay, it's fine. So we worked together. Then we wrote a paper on how to do this. I told him, well, since I'm consulting Bell Labs, you work for Bell Labs, we probably ought to give them the patent. Well, you take it to Bell Labs lawyers. Bell Labs lawyers then looked at it, and he called me back a couple of days later and said, well, they say they don't think they want to patent it because light's never been useful for communications, and so they don't think it's worth patenting for Bell Labs. They told me if we want to patent it, we just have the patent. Well, I realized that they were mistaken. I knew, of course, it could be used for communication. And Shaw knew that too, and I told him, well, you go tell them it can be used for communication. So they called me back and they said, well, okay, if you can write a patent showing us how to use it for communication as well as how to build it, then we'll patent it. So we did, and I thought the Bell Labs really deserved a patent. So you see, even those people didn't see any use for it in communication. Well, it's obviously needed to communicate. I also saw it with very intense power and cut and weld things and so on. There's a lot of science. I was especially interested in doing science with it. And I could see there were a lot of science as well as a lot of good technology. But you never foresee everything. You never foresee everything. And people keep expanding and expanding it and seeing more and more uses. That's characteristics of new ideas. They keep growing and the community adds to them.
When you first invented the laser, what were the uses that you thought of?
Oh, well, let's say cutting and welding and communication and doing spectroscopy and making very, very precise measurements. Making very, very, very precise measurements of time and of distance and position and direction and so on. Those are some of them.
But what was your role in the making of the radar system?
I really wanted to do basic science, but there weren't many jobs. I was back in the Depression years of the 30s. There weren't many jobs, but Bell Labs offered me a job, so I went there. They let me do science for a while. Then the war came along and said, oh, we want you to start working on radar. So I had to become an engineer, work on radar, and I learned all about radar. Actually, I was designing a radar to do radar bombing, using radar waves to direct the bomb to fall on the right thing. So I learned a lot from the engineers and learned from Bell Labs and so on. And I was developing a system. I wasn't especially inventing microwaves and how to make them. I was developing a system, a whole radar system to aim and drop bombs and direct them and so on. But through that, I learned a lot of engineering, which was very valuable in invention of the maser and the laser.